in the asynchronous class, it was on different types of data, different sampling methods, and then you create and analyze a frequency table. So after you have done your survey, you get your information, you create a simple frequency table. So the outcome here is to estimate the characteristics of population via statistical inferences. Okay, so you learn what is population, you learn what is sample, and then you make statistical analysis. Okay, you analyze first. That means you get the descriptive statistics, and then you make inferences. Then you have inferential statistics as well. So it's both. So this is one part of it. Next, the box plot is also same outcome. So same course learning outcome, but you learn it from a graphical analysis. Okay, so there are different types of data. So as I told you, there's qualitative and quantitative, and qualitatives are descriptive. Okay, then you have quantitative, which are numbers. Okay, and this quantitative can be discrete or continuous. Okay, so what does discrete and continuous means? So discrete data are the results of counting. So it's a whole number. You don't have decimal points for it. It's not, it doesn't have small breakups of it. And the most simplest example is the SMS. Okay, you can have 0 SMS, you can have 1 SMS, you cannot have half SMS. Okay, and another example is when you're counting person. So when I'm counting the number of students in my class, I can have 20 students, I can have 30 students. I cannot have 20.5 students. Okay, so these are discrete data. So it's very important, because how we represent a graph or data, we should not cross this boundary. Some data is best used for continuous. Some data is best used for discrete. So if some graphical inputs, okay, so if you cross this, if you use the wrong one, then the whole thing looks wrong. The whole data is represented wrongly. Okay, so that's why you must first know whether it's a discrete data or continuous data. For continuous data, it can be any value. It can take decimal values. So one of the example is given here is the pH. So your pH can have point. So it's continuous. It can be 0.4, 0.4, 0.56, 0.5, 0.5 to 1. So it can be continuous. Yes, thank you, Harsh. Okay, so height is continuous. So can you give me a few more example of either continuous or discrete data? Anyone? Unless you want me to call your name out.
Temperature.
Okay, temperature is discrete
Continuous.
or continuous? Yes, because your temperature has decimal points. Okay, two more person to speak up.
Number of COVID cases.
Doctor, you're muted.
Thank you. Thank you. Right, number of COVID cases, discrete or continuous?
Discrete.
Discrete, yeah, because you cannot have half a person. Okay, Tiu Jin Kai, good. Left-handed, yes, it's discrete because it's single, is person, right? You're talking about person. Okay, so these are the different types of data. So now you're in second year, right? Yeah, usually when you have your experiment presentation, right? I've noticed when they plot the graph, when let's say you plot a graph and you do a continuous line. Okay, you have different points and you do a line. You join the lines. Okay, when you join the lines, that is actually for continuous graph, continuous data. That means the data can fall anywhere. If you're having a discrete points, then you find the optimized value. You find the optimized line. Okay. Sometimes the student are presenting discrete data, but then because there is dots, they just join the dots. So that actually becomes wrong, because it's you only join the dots if it is continuous data. If it is discrete, you cannot join them. It becomes bar chart, or it can stand as a point. You can have points at different values, but you cannot combine them. Okay, this happens a lot in the second year lab presentation. Okay, I think probably this semester is PBL, third year lab. So probably next semester, this semester is first year and third year lab. So your next semester lab, you will have this. You will have to decide between the discrete and continuous. Okay, let me go back to the slide. I don't know if I'm sharing. Okay, I'm not sharing. Okay. Okay, so those are continuous and discrete data. Then we also have different sampling methods. So I remember I just mentioned to you, we have population, which is everything. Of course, if for example I want to know what Malaysians like to eat, the best thing for me to do is find out what every single Malaysian likes to eat. Then I get the best data, because every single person have answered. So I've got the favorite food of everyone. So I've got the best collection of data. But that is always impossible. It's difficult, it's costly, and impossible to get the entire population to answer you. So that's why a sample should have same characteristics as the populations it is representing. So if I want to have a good outcome of data, I must make sure I am sourcing for the data from a quality sample. My sample must be correct. My sample must be good to give me a quality data. So it's really important how you choose your sample. So that's why there's always if the statisticians will use this sentence, your outcome of statistics is only as good as your data is. If your data is bad, statistics will use the data, will use the maths, and to give you an outcome. But that statistics is only as good as the data is. If it's a bad data, the statistics is misleading. If you have a good data, then it gives you a good value. Okay. So there are a few sampling methods that I have listed here for different applications. Okay, so the sampling techniques can be probability sampling techniques or non-probability. Okay, so probability meaning to say you want to have a better representation of a certain idea. So you want to do good sampling, good probabilities. That means maybe you want at least representing 80% of what the actual population is. The sample must give you an idea of at least 80% close to what the whole population will want. Once you get the trick of it, I think you will understand what it is. So simple sampling is each member of the population has an equal chance of being selected as a subject. So this is a simple simple random sampling. Okay, so you independently put your samples and then you just pick. You have no criteria to pick them. There's no criteria to pick them. You just you can even close your eyes, blindly pick some samples. They can be close together, they can be very far apart. So that is the simple sampling. Okay. And the simple sampling is subdivided to lottery, coin tossing, moving number wheels, table of random numbers method. Okay, so this simple sampling, you can also computerize it. You can also do it methodologically. So they have some methods of simple sampling, such as lottery, coin tossing, and this moving number wheels and so on. So this is more like a lottery. Okay. Oh, this is lottery. So this is like, for example, you have a population, you just pick, like I just told you, you just pick any, and you could have picked any of this person. That's why it stands an equal chance to be selected. Okay, this is simple random sampling. And it's possible to repeat the samples as well, as you can see. That's what they're trying to show. Because you put them back. After you sample, you put them back. So you can select the same numbers again as well. That is simple random sampling. So the lottery method is like that, isn't it? So the blindfolded researcher picks numbered text from the hat. All the individuals wearing the numbers are the subjects for the study. That means you name the subjects in numbers, then you put them into a bowl, then you just pick the numbers and they become your subject. That is the lottery method. Okay, so we have numbers, you just pick them. Suppose we have 500 units of population, you want 50 of them, you assign numbers 1 to 500 and then you just pick 50 and then that becomes your samples. Coin tossing methods. So is head or tail. Okay, so we can use head or tail methods to select which samples that we want to use. Okay. And then moving number wheels. So this wheels moves and drops the numbers. So you can pick the numbers. So these are your samples. So you didn't select, you didn't decide what is this, what numbers that you want to do. It's chosen for you. Okay. Then you have simple numbers, simple random numbered table. So you number the tables, then you identify two, you just circle two numbers, any two numbers. So any numbers that have an owner. So these are the owners. You already listed this earlier. You already listed this, and then you just find 2 digits. You just circle, circle, circle. Whichever numbers that has an owner, those are your samples. Okay, these are ways that they do things. This is to prove, because you want to show proof how I selected the simple random. Okay. So when you use the random tables, you can also happen to choose something that is outside the numbers that you already have. Then of course you'll get rid of it and then you just use whatever that is within the number. Okay, let me just check time. Okay, then you have computer aided sampling. Again, you put the numbers, computer will just randomly give you numbers. If you have learned math lab, okay, you probably didn't have time because you're in the second year. First year, you should have got math lab. If you actually key in R&D numbers, if you put a bracket, it will give you random numbers. And you can put between 1 to 100, how many numbers, comma, how many numbers that you want, it will give you the random numbers. So computer can also do the sampling for you. Okay, so this the advantages. So it is representative of the whole population because you are fairly choosing it. Then it also have disadvantages because it needs a complete list of all members of the population, and which is usually not available. Okay, so you also have stratified sampling. Okay, so this one you divide the entire population to a subgroup. That's what we call strata. Okay, if you own a condo, if you're going to buy a condominium, or your parents bought a condominium, you have strata title. You would have come across this word strata title. That means they give you a parcel, that the whole parcel is owned by you. So that's strata. So you parcel it, you subgroup the entire population. Then you randomly select the final subject proportionally. That means, let's say I have Malaysia. Malaysia has 13 states. I want 10 samples from each state. So each state you randomly select, but each 13 state, each state will have 10 samples. You'll pick 10 times. That's your strata. Okay, and then you have okay, so this is strata. It's still random, but you actually have a parcel to it. I want Caucasians, any random Caucasians, but I want 10 Caucasians. I want African Americans, 10 of them. Hispanic American, 10 of them. Okay, if let's say I don't have this Caucasian, I don't have this line, I say I just want Americans, 100 of them. That is random sampling. They can be more Caucasians, more of each one of it. That doesn't matter. I just want random. So that is random sampling. Okay. Then you can have cluster sampling. All members of this strata are members of the cluster sample. Okay, cluster sampling, you divide the population into strata, then randomly select from some of the strata. That means you don't decide each strata I want to take 10 people. No, it's not like that. You put the stratas together, you already divide them, but then you put them together and then you just pick. Some of the stratas may not get selected. Okay, so this is cluster sampling. Usually this happens in our academic performances. Actually they divide the student into separate cluster like north, south region, central, and then on the other side, Sabah and Sarawak, they always put it aside, East Malaysia. So so that becomes a cluster. You just pick from certain group of stratas. Then you have systematic samplings. Systematic sampling is the easiest for you to understand, where let's say you have 100 samples. You pick every number 5 of the sample. 5, 10, 15, 20, 25, 30. So that is systematic sampling. Okay. Okay, so you have exact intervals and then you pick the numbers. That's systematic sampling. Okay, and it has its own advantages and disadvantages. And convenient sampling is like how I mentioned to you, is when you choose your easily accessible survey subjects. That is convenient sampling. Right, okay, so those I've explained the samples that has been introduced to you. So I believe you went through this quiz, and each of the samples only is only for what should I say, one sampling method for one sentence. So if you keep trying, then you definitely get your answer. You can keep trying, so no worries. And I think most of you got the answers. Okay, and then you were introduced to frequency. Okay, so you had relative frequency, cumulative frequency. Then I gave you some examples to understand what cumulative frequencies are. Okay, so this must be very simple because you've done this in schools, and then it's just refreshing your memory. So when you have frequency, it is for each parameter you have a frequency. Okay, then relative frequency is for each parameters relatively to the total number of the frequencies involved. Okay, then you have cumulative is this relative frequency, you add it up every time you add it up, so it should reach 1 at the end of the frequency. Okay, because this relative is taking this whole frequency and then is finding out from this whole 20 frequency how many percentage is 2 hours. So you got this value. So if this is divided by the whole of the frequency, your cumulative should reach 1. Okay, this is sort of checking. Okay, and then we had some application questions on how it's useful. How do you use these tables? Okay, so I believe this is quite simple and you understood. Do you have any question on this? Any questions on these frequencies? Okay, so then you have this bins. This one is given to you. I'm not sure let me check. The assignment, wait. If you were to do select your bins yourself. So this was the assignment. So this one, for question 1, you come up with, I already have the answers for you, right? Question 1, okay, so you are to choose your own bin size. Okay, so how do you choose your bin size? Okay, anyone would like to answer? How did you choose your bin size? Anyone? How did you choose it?
Looking at the minimum and the maximum.
Yeah, yes, you use the minimum and the maximum, right? And what did you do after that?
Try to make interval of it.
Okay, did the Excel help you to do the bins? Was there an additional, because the Excel gets updated, so some things becomes auto. So does the Excel give you the bin size, or you decide the bin size?
Decide myself.
Okay, how about others?
Also decide myself.
Decide yourself. Okay, so when you decide yourself, what do you base on? So how do you decide whether it's 4 or 5 or 6? Some of you might just followed my answer. You could have done differently as well. So how do you decide? Any idea?
Based on the question?
Based on the question, yes, that's true. Because sometimes the question gives you an idea, right? Like they ask you less than 5 kilometers, more than 10 kilometers. Okay, that's one. Another way is, of course, yeah, you should look at the questions as well as your minimum and maximum. And usually the bin size are between 3 to 5. But if you have a lot more numbers, you can also go up to 10 usually. Okay, why? So you will have one. Sorry, where was I? Because you need to have one minimum, one maximum, and then you will have the middle numbers. Okay, so the last bin and the first bin, if possible, like you don't choose a bin where it doesn't really fill up. the first, or usually the last one doesn't really fill up. Let's say if I choose 18 to 20, then I will probably will not have 7 frequencies. So we want to divide it equally so that it's also inclusive of this maximum. Okay. Right. And then you also to build a table for this. Okay. So he was trying to be inclusive of this number of 48. So this table we can also do between 1 to 50. Wait, 1 minute. Hello. Okay, but then again, this is probably because of the question, right? It requires use for 6 months, 12 months, 24 months. That's why your bin is in that size to be able to answer the questions. Okay, all right, I only give 2 questions. Right, so any questions for assignment 1? Yeah, it was the first assignment. Assignment 1? Anyone faced problem?